So today I will be performing the lab project part, the laboratory part of this project. And in this project, I will be testing the concentration and the acidity of two different coffee brands. As I stated in the observations section, there are people that complaining about having some issues when they drink espresso coffee but, from one brand, but they seem not to have any problems drinking from another one. So in this experiment, I will be testing the concentration of two different brands of espresso coffee to check if the concentration of caffeine and the acidity in it are responsible for unlocking the heartburn discomfort. So we will be testing which one is more prone to cause heartburn. So gastric juice contains hydrochloric acid. This one is a strong acid, essential to decompose food in small nutrients, allowing the body to absorb them. So when this acid interacts with the weak acids contained in coffee, causes an imbalance in our stomachs, and acid amount in the stomach increases, giving as a result a reflux and sometimes heartburn, according to the website Very Well Health. And the article, Tips to Brew Coffee That Won't Irritate Your Stomach. So we'll be doing today is what we're going to do today is we'll be working testing the concentration and acidity of two different brands. This brand, Café La Llave espresso brand, and the Cubita brand, another espresso brand. So we'll be performing two different processes. The first one, the osmosis. So let's start. So for the first one, we will need a graduated cylinder. We will need a dialysis tubing. So dialysis tubing, where we have it here, pre-soaked, and dental floss. We already have it here. We will need two beakers, beaker 1 and beaker 2. And both, we're gonna fill both beakers with 99 milliliters of deionized water. So let's start with that process. So we will be doing this to test the concentration. Let's see which one of both brands are more concentrated. So we have, oops. So we said 99. No, we have to use another beaker for this. 99. Beaker 1, 99 for beaker 2. We already did the coffee, the espresso for both. And what we have used for these two different espresso is the same amount of substance. For example, we used for both, we used 80 milliliters of water and 20 grams of coffee for make the espresso coffee. So now what we are going to do in beaker number 1, we wanna add 1 milliliter of coffee. We have here 1 milliliter. So we don't have any contamination here. So for the liquor too, we will be adding 1 milliliter of, 1 milliliter of Cubita Espresso to liquor number 2. It will be swirling a little bit. And we have this 1% coffee solution. So now we'll be working with the dialysis tubing. We have it pre-soaked here. Both. Okay, and we'll be sealing one side of the dialysis tubing, and we will use a dental floss for that. Okay. Oops, I'm gonna need a smaller one. Twist it a little bit, twist it a little bit, and this side is already sealed. So now we're gonna add, according to the instruction, we will be adding 15, milliliters, 15 milliliters of each. So this one is La Llave Beaker 1. We'll be adding here. We have 5 more, 15, oops. Okay. I think we can add 5 more to make it 20. Make it 20. So we have 20 milliliters of this coffee. The first one that we want to be testing. This flow is a little tricky. What? Here we go. So we will be soaking in the 1% solution from La Llave, and we will be waiting for 5 hours to see how the concentration varies from this one to the other one. So we want to be repeating the same process with the other brand, the Cubira brand. So we will be doing the osmosis process for this one too. Oh, wait, actually, I think I forgot one step. We have to measure first the weight. We have to measure the weight. We have a scale here with me. This one is 3 grams. Exactly 3 grams. So I'll record that number. So Llave initial 3 grams. Okay. Initial weight. Okay. So now we will be doing the same process for the other one. We will be sealing the dialysis tubing. We will add 20 milliliter, 2 milliliters. We have 1 milliliter. We're going to do both. Not 20 milliliters, just 2 milliliters. 2 milliliters in each. So now we want to be twisting the other part, the other side. The other side. It's already twisted. And we will be recording the weight. Let me see, this scale has a little problem, I don't know. Okay, 8 grams, okay. So we have the same 3 grams, and we want to soak it in the one solution, Cubira 1% solution, Cubira coffee solution. So here we have both. Beaker number 1 for La Llave, beaker number 2 for Cubira. So we have to wait 5 hours until we see any results. So when we return, we will be testing, or we will be measuring the weight of this substance. So now I will record Cubira initial was 3 grams in weight. So when we return to do the last part of this project, we will check if any changes in weight has occurred. So the next step of this lab part is analyzing the pH of each uh, of these substances. So we have here La Llave, we have here Cubira, and now the instruction says 25 milliliters of La Llave coffee must be poured in a beaker to check the acidity. The red litmus paper must be submerged and the color must be recorded. So we have these two here. We have about 80 milliliters of this coffee. So we want to be doing this here in this same, and we will be the result for that. So here we have the red litmus paper. So this one, we will be testing, or we are confirming that we have some acids in these substances. So we have to wait for a little bit. This one is the Cubira. We will be waiting about 3 minutes, 2 minutes or 3 minutes until it dries, and we will recording the color that we supposed to have. So what we are proving with this process is that we have acids in coffee and in both coffees. So we have to prove that we have that acid. Another thing that we can do, as this part of the project says, we have to, or we can measure how which one is more acid, which one of both is more acid. For that, we need a pH meter, this one that we have here. So we will be measuring both. Okay, so let's check the first pH. Okay, for La Llave, we have 5.04 in pH. Let me clean this up for no contamination. For the other one is Cubira. So let's begin again with So now is the turn for the Cubira Espresso. So let me check the pH. We have 510. 510. So this one, Cubira, is a little more basic than La Llave. So probably La Llave has a lower pH. That means that that means that probably like agave gives more or have more probabilities to cause heartburn. So the other part, we have checked the color of these two different coffee. We have this bright red. We have bright red for beaker number one. I mean beaker number one, which is La Llave, and beaker number two, we have the same color. This color proves that both have acids in it. And I have some information here. Some espresso pH fluctuates from 4.5 to 6. So both that we are testing this time are in this range. So this is all for this lab. We still have to wait until 5 hours until we can see any results in the osmosis process. So until that time, I will be pausing the video, and after that I will continue to see what happens with this both osmosis process. So 5 hours have passed, and I will be analyzing the weight with our osmosis process. We will be weighing the dialysis tube, and we will see if we have any result here. So let's begin with beaker number one. We will be weighing the La Llave coffee. Okay, so I'm just trying to put the correct unit here in the balance. Where is grams? Here we so this one, the weight has raised until 4 grams and 0.2. So we can say La Llave final weight 4.2 grams. Okay. So now I weigh the Cubita coffee, and we see how much is it, how much the weight is. So this one looks like 3.7. So the final for this one is final 3.7 grams. Okay. So now what I want to do is I want to measure the pH again, because I want to see if any change has occurred in both when the time passes. So I will check after 5 hours the pH of both coffee. So starting with this one, okay, with the cubilla, I mean la llave. We have 6.6, I mean 5.6, 5.06. We have 1.3 in this one. 5.6 in la llave, 5.03 in cubilla. So that is all for this experiment. Hopefully I can come up with some figures or some numbers that I can use to prove my theory or my hypothesis about which one can have more negative effects related with the hardware. So that's it. That's all for this experiment. Bye.